Hello and welcome everyone. Welcome to this course of Fortinet on my YouTube channel. I'm Zubair Altaf Qureshi, and in this video we will be talking about the Fortinet firewalls. Now, just to let you know, Fortinet firewall is said to be the term is next generation firewall. Let me take my this. So Fortinet is basically a next generation firewall. You might have seen this word NGFW connected with most of the firewalls nowadays. So your FortiGate firewall is basically a next gen firewall. Now we need to, if you want to understand what is a next gen firewall, you need to understand what firewall is and the generations of the firewall, right? Now, one more thing that you have seen the Fortinet and the FortiGate, right? What is Fortinet and what is FortiGate? You need to be clear about this. So Fortinet is the company and FortiGate is their firewall. Now they have different products as well, right? So they do have a Forti manager. They have a another appliance called the Forti ADC, which is application delivery controller, a load balancer basically. They do have Forti web and they do have the uh, Forti analyzer. Right. We will be touching the Forti manager in this series, and they have the Forti analyzer, right? Analyzer. Okay, so they do have different variety of products, but the main company is Fortinet. So hope that is clear, right? Now the main question comes: what is a firewall, right? And why we need it? Why is it needed? Why is it needed? And secondly, we'll see the types of firewall that we have, right? And that is it. And also we'll see the generations, right? The generations of the firewall. Yeah, so we have to cover a lot. So let's begin. The first thing is what is a you can say the firewall, right? What is a firewall? And so I mean the answer could be as simple as saying firewall is a application or a device that basically filters the traffic. As simple as that, right? But if you want a more sophisticated definition, you can just think about this as a firewall, which is a device or a software, is basically an essential layer of your security that would act as a barrier between your private networks and the outside world. So from the first gen firewall to the stateless firewalls to next generation firewalls, firewall architectures have evolved tremendously over the past 4 decades. Now, today, organizations can choose between several types of firewalls, including the application level gateways, which are called the proxy firewalls. Then you have the stateful inspection firewalls, and then you also have something called the circuit level gateways, and even use multiple types simultaneously for a deep layer comprehensive security solution. For example, you you could see that you have a, let's see, instead of this one you could have a perimeter firewall, right? As in design in today's network. This is the perimeter firewall, and this could be any provider, right? This could be a Palo Alto, this could be a Cisco, Firepower, this could be a Fortinet, Fortigate, I should say, Fortigate firewall, right? This could be a checkpoint firewall. So this is on your perimeter. Now inside, what could happen is once the traffic is inside your LAN or inside your corporate. So this could be your DC, and I mean the architecture could be so much different for every organization. Like I'm just trying to take a simple example. So this could be your perimeter firewall, and then coming inside this could be your router, right, of your company. And then from here you could have multiple layers of switches, the layer 3 switches. And from layer 3 switches you could have again um, the firewall, again a firewall, which could be actually um, controlling the traffic for, say, some of the web servers. Okay, and then from here you could again have an access layer switch, right? That could connect like multiple switches like this. Now you will not have a single switch. Obviously, you would have a multiple um, L3 switch here and could connect like this, and they could all also be connected, right? But now the point is you could have the endpoint users here, like the employees and all, and on that also you would have some sort of antivirus, right? Antivirus. Okay, you could have a firewall here also. Now that could be a software firewall as well, right? Software firewall, like in your Windows systems, you do have firewalls, right? You could define rules in that. You could allow or block the traffic there. So depending on this type of architecture, you could have multiple layers, right, of protection here. You could have a firewall here, you could have a firewall here, you could have a firewall here. And also there could be like proxy devices. Have you, if you have heard about this proxy firewalls, you can say, or you can say these are like application firewalls. For example, for these users to go to internet using HTTPS, right, you would have to specify a proxy setting in it in the browser itself, and that traffic would go via this to the proxy firewall, and through the proxy firewall, if that is allowed, um, it will go to the public internet, like that, right? So this here can actually control that traffic of that application, right? And has the visibility of what is happening there, like who is doing which website, and then you can have the power to block the website, you can monitor it, you can send it for analytics and whatnot, right? So depending on the type of organization, you could have different architectures, right? That is the whole point of this design. Now let me just clear this. Now coming back to this, I would like to show you that if you go to your Windows system and type like the firewall, Windows firewall, you would have something like this, right? So you have the firewall. For me, if you go and say um what advanced settings, and you could basically go here and have inbound and outbound rules, right? So you could block the inbound traffic from here. You can have a new rule, right, which says the port number that needs to be maybe is a TCP or UDP specific ports. If port 80 as an example, TCP port 80, which is HTTP, allow the connection if it is secure, block the connection, I want to block every HTTP, like that. So you have this kind of firewall in your laptop as well, in your Windows PC. Likewise, you have IP tables in Linux systems, right? Now the basic question is, what is a firewall, right? So a firewall is a security tool that can monitor incoming or outgoing network traffic to detect and block your malicious data packets based on predefined rules, like you saw the rules here. So you have these rules in all the types of firewalls, whether it's a network based firewall or a software based firewall or a proxy firewall, and this would allow only the legitimate traffic to enter your private network. Now, this could be, as I said, could be implemented as hardware, software, or both. Firewalls are typically your first line of defense against malware, viruses, and attackers trying to make it into your organization's internal network and systems, right? So this is your first line of defense, much like a walkthrough in a metal detector door, right? At a building's main entrance, a physical or hardware firewall inspects each data packet before letting it in. Now it checks for the source and destination addresses, and based on predefined rules determines if a data packet should pass through or not. So for example, if I would have blocked this TCP port 80 traffic, then my firewall will not allow any TCP packet on port 80 to come in incoming, right? Incoming, ingress. So you need to understand this incoming and outgoing. Hope you would have done the ACL in CCNA days. Ingress and outgress, egress, you can say, incoming and outgoing, right? And once a data packet is inside your organization's intranet, now it has passed through your perimeter firewall, right? Now it is inside your intranet. Now there also you need a software firewall that can further filter the traffic to allow or block access to specific ports and applications on a computer systems, much as like I showed you in the Windows firewall, allowing better control and security from insider threats. Yeah, so this is multi, I mean, this can be a multi-layer architecture as well. The security, it's a big domain, the security, right? And the network firewalls are a part of it. An access control list may define specific internet protocol IP address that cannot be trusted, right? You could have a router which could basically block a particular IP address which your organization doesn't trust. I mean, there are so many databases which have which define the reputation of IP address. So based on the reputation of the IP address, you may have an access list on the routers that are denying those IP addresses upfront. Right, the firewall will drop any data packets coming from those IPs. Alternatively, the access control list may specify trusted source IPs, and the firewall will only allow the traffic coming from those listed IPs. So in this case, what you could do is first you say block any, and then you whitelist the particular IPs. Okay, there are several techniques for setting up a firewall. Now you could have, as I said, you could have a software firewall as well as a hardware firewall, right? So I mean that would be, I guess, like enough um, for the time being, and you can, if you want, you can read more about the firewalls and all. But the next thing that I want to cover is now the why, right? Why do we need it? Like if you think about a decade back, I mean 10 years back, right? um, the internet was not safe, I would say. I mean, it was not this risky to be on the internet as it is now, because the hackers and the scammers and the attackers are becoming smarter day by day, and they are also learning, right? So our devices, our network firewalls also need to be smarter. The attacks are getting sophisticated day by day, and so should our firewalls get sophisticated and have a lot of features, right? But at the cost of the performance, obviously. But you would have to have good number of resources to basically run those features. Now, keeping that aside, the firewalls would or can be divided into four types, if I say. Now, just to make you understand, right? And also we can specify the generations of that. So I would go for the Gen 1 as the packet filtering firewalls. Packet filtering firewalls. These would be what? These would be like any device that knows access control list, right? So this could be, but extended. Okay. Uh, so if you know about a thing called the five tuple, this would be easy for you. Now in networking terminology, this five tuple means the source and the destination IPs, right? Source and destination IPs. Then you have the source port. Then you have the destination port, and then you have the protocol number. protocol number. Now, on basis of these 5 fields in your header, your device could either allow the traffic or block the traffic. So you have that power. So this was the first generation firewall, or you can say the packet filtering firewall. These were not, I mean, if you think about it, it gave you a lot of control, but these were good for the I mean, for the older days, but it is easily penetrated nowadays because there are so many tools that even the new hackers, which are called the script kiddies, could I mean, bypass this kind of firewalls nowadays, right? Because you have lots of applications available nowadays. Now, what this used to do is, based on that, those fields in the header, right, you could allow or deny a traffic. For example, I could say I have a firewall, this one here, and this one is my 10.2.2 dot say 10/24, and I say I'm this firewall. I don't want this guy to go to the internet mm, when it is trying to for example go on say 443. I mean HTTPS. I don't want this to happen. Or even I could say I don't want this to use EIGRP, right? So what I would define as the source, which in my case would be the 10.2.2.10 /24, right? And then destination would be, so where you want to block this guy to go. So for example, I don't want this guy to go anywhere on the internet. Okay, so I would say 000. I mean all the internet, right? And then I would say source port could be random. I would say any, right? Anyways, when a device generates the source ports, the packet, the source port could be random, so you cannot I mean specify the source port here, but the destination port I know that this should not be 443, and the protocol remains like that, right? Because I don't want the in the next one I would say 88 for the protocol for EIGRP. For example, I don't want someone to have a EIGRP neighborship with this R7, right? So that is the packet filtering firewall, simple as that. If you know ACLs, so any device that knows ACL can behave like a packet filtering firewall. Now, if you talk about the packet filtering firewall, it had advantages, and also it has had disadvantages, right? Advantages. Now let's quickly discuss that and move to the next one. Now, if I talk about the advantages, it was can have, and this can be a single device and can filter traffic for the entire network, right? As I said, can be a single device and can filter traffic for the entire device, entire network. This would be extremely fast compared to other types of firewalls, extremely fast. Okay, and what else? This could be inexpensive because your router could be doing the same thing. This could be very inexpensive because you would utilize the same what do you say, a router, and also this would require minimal what do you say, minimal resources, um, right? And yeah, that would be all. And you would not see network performance and end user um, getting affected by this much, right? Now, talking about disadvantages, so because traffic filtering is basically entirely on the IP address and or the port information, packet filtering lacks basically the broader context and information other that basically informs the other types of firewall. For example, it doesn't have something called as the application layer, or you can say application awareness, which the proxy firewall would have, right? And the next generation obviously firewalls would have. So this would be one of the disadvantages, and this basically doesn't check the doesn't sorry check the payload, right? Payload of the packet that it filters. uh, that's why I said this is the first gen is not, what you say, intelligent. And in nowadays what happens is you could easily spoof an HTTP packet. So for example, you do say this is port 80, and the packet filtering firewall would look on that port and say, okay, this port 80 is allowed, right? You can go. But inside that you might have a malicious traffic inside the port 80 header, spoofed, right? And this firewall would have no idea about this of this type of attacks. So not an ideal option for every network, right? So this could not be an ideal option for every network. So yeah, so let's move on to the next one, which is basically the uh, stateful firewall. Now, you might have heard about the stateful inspection. So there are two terms that I want you to understand, which is the one is the state less, and then you have the stateful. Yeah, people who are aware of the AWS, for them it is going to be easy. So you have the security groups and you have the NACLs there, network ACLs also there, right? So security groups are stateful, and the NACLs are stateless. Now I would quickly try to explain you this. What is stateless? Stateless is because basically something which does not save or retain or save, basically not retain, save the session information, which does not save the session information. You would call that a stateless firewall. And stateful is something which has a um, retention of the state table, which maintains the session information, right? So it has something called as the state table, wherein what happens is, so for a stateless, what would happen is, for example, I want to this firewall, this user to be allowed to internet. So I would go here on this firewall and say, okay, this guy 10.222.10 going, so this is the source, this is the destination, and I would say, okay, destination is any 0000 /0, and then I have the source port as any, and then I have the destination port as, say you can say 80 and 443, and I would say the protocol TCP, and or you can say the protocol TCP or application, whatever, um, and I would say this is allowed, right? Action is allowed. Fine. So this traffic goes to the internet. Now, when the return traffic comes back, the firewall would again check, because this was on this port. Now, on this port, you don't have any ACL, right? Or any access policies. Now, in case of stateless, this would not work. So you should have another rule that says rule 2. This is rule 1. Now this should be a reverse of this, right? So this should be any, because you will not be able to what do you say, no, there are so many IPs that your Windows PC would want to go, right? So for a rule to be specific to that particular user, and you might have hundred of user inside your LAN. I mean, you do understand the complexity right here, and the problem that you would run into quickly. So you would say, okay, 000 going to 10 to 10 any, and you would say what destination would say obviously 80 and 443, um, and action allowed. Now here what would happen is the ports you don't know, so you have to say any here, because now the ports would be reverse, right? So what was the source here would be the destination here, right? So you don't know that. So it's very tough in this case to have a manual this rule on here. Now you could do is allow everything, any, but then again this if you allow any from this side and any from this side, then what is the use of a firewall, right? So in this case this is called a stateless. It was very difficult for administrator to basically have all these things configured. Now came the stateful, which basically automatically retains all these information here in a state table, and it knows that what source IP went to which destination IP, and what was the source port and what was the destination port, and also the port and the protocol, right? The protocol, the port is already captured here, so this would be the protocol. The port is here, source port and destination port, and the protocol, everything it keeps in a state table. And automatically when you uh, what do you say, create a rule from in to out, it automatically would create a reverse, or you can say a mirror rule here in the state table, which would allow the same return traffic onto port number 4. So you don't have to do anything. It is by default automatic that it creates the stateful firewalls will maintain a state table, and because of which you would not have to define a rule for that particular traffic to come back, right? So that is the stateful and the stateless firewall. Now this concept was basically patented by Checkpoint. I don't remember the actual, I think it was 1997, but you need to Google this. But yeah, this has been patented by Checkpoint. The stateful concept of the firewall, and also they did have the first NGW NG firewall, right? NG firewall, which included the stateful as well, right? So that is the stateful and the stateless concept, and now you would know what is the difference between a stateful and a stateless firewalls, right? After that came the mm, now this was the second generation and the third generation. Now after that came the I would say the proxy firewalls. Now proxy firewalls are basically like an application firewall, which would basically so for example, a proxy firewall you would mostly see in the organizations, wherein you would have to basically define the what do you say, the proxy on your browsers. So if I go to this, and I think I would see a proxy here, uh, proxy, yeah, open computers proxy setting, and when I go here I would have to define the yeah, this one, use a proxy server. Now this proxy server would be your appliance that you have in your organization, right? For example, this is your proxy server, or this is your proxy server. So in case now this would be for just the web browsing, right? So if you want to browse the internet, you would basically send the traffic not directly to that web server, but first you would send it to the proxy server, and the proxy server would check the rules, the policies, and based on that, the action would be taken. So that is your proxy firewall. But proxy firewall are more powerful because they do have the application visibility, right? You cannot application level visibility, so they do know if you are spoofing some other traffic inside an HTTP traffic, right? So they do know how the HTTP packet would behave and how it would look like. They have that intelligence. So that is the packet proxy firewalls, right? And nowadays the firewalls can also behave like a proxy. They do basically. That has a good reason why they do, and we will get to know that in the future. lectures, right? Now, the last one that I want to talk about is the next generation firewalls, NGFW, next gen firewalls, and this is what we are going to talk about in the Fortigate firewalls, because the Fortigate firewalls are also next gen firewalls. And now, what is a next gen firewall? Now, next gen firewall would obviously have the first gen capabilities, which is the packet filtering power, and they would have the second gen and the third gen capabilities as well, which is the stateful and stateless, right? That concept. And then you would also have mm, the proxy features, obviously, proxy firewalling capabilities. Now you could do in to out to in, or both proxying. That is possible. Now, next gen firewall capabilities include um, something. Oh, sorry. So next gen firewall capabilities would include antivirus capabilities, URL filtering capabilities. Now, what is URL filtering? Obviously, you would know. If I don't want my employees to visit Facebook, I could block them using the URL filtering feature. URL filtering has categories. We would see this categories, and then you can have only your uh, um, custom rules as well for the URL, right? But the categories, for example, are like you have social media capable categories, you have adult categories, you would have what do you say, medical categories, you would have drugs, you would have games. So you could, for example, you don't want all your employees not to visit any of these, and would have banking extra, right? Or else you could do something like star means anything dot google, right? Google dot star, so you are blocking anything related to Google. Okay, so you could do this something like this and block the traffic with using the URL filtering. You would have the capabilities of something called the identity awareness in the next gen firewall, which means you integrate your AD or the TACAC server. And then what happens is your firewall basically has the knowledge of your users, of your user IDs basically, and based on that you could define that in the rule, in the policy, in the access policy. You could define the name of that user, and based on that user ID the action could be taken. So you understand how deep this is, right? So you, for example, you don't want a user called Zubair to access internet. Now Zubair could be smart and he could change the, and now if you do on the IP level, I could go on to my desk and connect, and maybe my desktop is having an IP of 10.2.2.10, which is being blocked here, but I'm smart and I say, okay, I'll go and take that laptop or desktop from one port and connect it to another port, and I would receive a different IP from the DHCP this time. And now that rule would not be valid for this IP, and I would be able to browse the internet, right? But in case of the user ID, once I log into my AD, I have been identified as the user Zubair, and because I am in part of that rule which says Zubair, user Zubair is blocked. So whether I am on this IP or this IP or any IP in my LAN, I would be blocked based on my user ID, because the firewall has that visibility now. And that is one of the um the coolest thing that the next generation firewalls has. Now different firewalls calls this with different names, for example identity awareness, user ID in case of Palo Alto, like that, right? So this is another feature. You would have anti-spoofing protection, right? You would have that in the next gen firewalls. wherein it would know which IP should be coming from which direction, right? So that is the anti-spoofing. You would have the proxy capabilities, which is basically called the HTTPS inspection. If you would have heard this word, or you have the SSL offloading is another word that you could use for that. SSL offloading. So these are some things that you would have VPN as well, VPN capabilities on these firewalls, and many more features. If you let me just rub this and let me show you the Fortinet client here. And if you go to the here, yeah, security profiles, you would see antivirus, web filtering, video filtering, DNS filtering, application control, intrusion prevention, SSL inspection, application signatures. So these are the next generation capabilities that I was talking about. So yeah, so that was the concept of your types of firewalls, why we need a firewall, what is a firewall, and all that, right? Now coming to the last thing that I want to talk about is um, which firewall architecture is the best, right? Now when for example, if I go here, sorry, so the question now here is which firewall architecture is the best? You have so many firewalls now, right? So you have so many options, what you do, what not to do, right? So this is a big question here for every organization. Now when it comes to this question, I would say and most of the security architects would say the same. When it comes to selecting the best firewall architecture, there is no need to be explicit on this, right? It is always better to use a combination of different firewalls to add multiple layer of protection. As I said, you would have a perimeter firewall, then an application firewall, then on the endpoint you might have another firewall. So this is a whole new multi-layer architecture which has the protection, because that it becomes more complex for the hackers to get inside and then have multiple layers of protection to be hacked into, right? Now for example, one can implement a hardware or a cloud firewall at the perimeter of the network, and then further add individual software firewalls with every network asset. And besides, the selection usually depends on the requirements of any organization. However, the some of the factors can be considered for the right selection of the firewalls, and that could be like, first of the thing is the size of the organization while selecting vendor or an architecture organization. This point needs to be kept in consideration, right? The size organization. If an organization is large and maintains a large internal network, it is better to implement such firewall architectures which can monitor the entire internal network. Now in that case, you would have to go for a large type of resource of firewall, because each vendor, right, whether it's Fortinet with its Fortigate firewalls, whether it's Palo Alto, whether it's Checkpoint, they have a range of appliances based on the type of organization you have, which are called a SMB, like small medium business appliances. Then you have moving downwards, you would have the data center level, what is it, data center firewalls, right? These are like chassis based firewalls with huge RAM and SSDs and everything, right? And many ports like that. Now this is one thing that you need to take in consideration. Second is the availability of the availability of the resource. Like, as I said, right, the resource is this. whether you have a data center firewall or you have a small medium firewall. If an organization has the resource and can afford a separate firewall for each hardware piece, this is a good option. Besides, a cloud firewall may be another consideration. Nowadays the cloud firewall is the new concept, wherein you have something called if you have heard about something called Prisma Access from Palo Alto. This is a cloud firewall, wherein what Palo Alto does is they spin up an instance of the firewall on multiple regions inside any vendor like the AWS or GCP, and they provide the access to the client, and they can basically log into the firewall, and all the traffic is passed through that cloud firewall and then goes to the internet, or maybe a DC. Depends on the type of routing they do there, right? So again, depends on that availability of your resource for that organization. And requirement of another one would be the requirement of multi-level protection. Of multi-level protection. Is it required or not? Like, right? This you need to be familiar with. If the organization is way too small, then you might not need the multi-layer protection, right? You may not need multiple firewalls there because the organization is so small. You're not hosting any web applications on premise, something like that, right? So these are the things that need to be kept in consideration while you uh, are selecting a firewall. So I think this is all for this lecture, and hope you understood and enjoyed all the points that I discussed about the firewalls in general. And we would see the Fortinet or you can see the Fortigate firewalls in the coming lectures. So that's it, and goodbye from me for now, and I will see you in my next lecture. For now, bye bye.